problem is minimum flips to make A or B equal to C. So we will be given a three positive integers. We need to return the minimum flips required in some bits of A and B in order to make A logical not but shift or B equal to C. It's bitwise or operation. Make a note of that, please. Flip operation, we know we can change a bit to 1 to 0 or 0 to 1. Lead code has given two test cases that are the most important ones that we need to take care of. The easier one would be example 2. I'll show you it first. Binary form of 4 will be 100 and binary form of 2 will be 010. OR of 4 and 2 will be 110, but C in its binary representation would be 111. So you notice that uh, rightmost bit is not same. So only we need to change only one bit, either from 4 or either from 2. This will make our task. We do not need to specify what bits which are changing, just we need to return the count. So this could be a hint that that will help us in reducing the time complexity. You will notice that I have done it by myself in logarithmic of time complexity, which will lead us to a better optimistic solution. And the second test case is, which is a little important one. Here we notice that if, let me explain you the question first, example first. 2 will be 10 and 6 would be 110, right? OR operation of this two integers would be 110 and binary representation of 5 would be 101. There are two bits changing, but our answer is 3 because the OR operation would result into a true value or either say a 1 bit value even if one of the bits in its input is 0, which means either of bit is 1, which results that would result in the 1 bit of our answer, and that we need to take care of that. We need to turn off this both the bits of A and B in order to make this 0, right? So the our count will be incremented one extra time to reach into the so that our answer could be 3, right? Let's move towards the coding part. First of all, you need to make uh, you need to have a better understanding of how we are going to calculate what bits are different. So that we are going to do with simply by XOR. We are going to OR A and B and then XOR it with C, right? So this will give us how many bits are different, how many bits are different from A or B and C. The only task we will be left is checking on these particular bits. Why are they 1? And we will increment the counter by our logic that we will discuss in further video. Now I have set counter to 0 and the bit that we are currently tracking is set to 0. Now I will be running a while loop over until until our num is greater than 0. If num and 1 equal to 0, which means that the rightmost bit of number is 1. If it's 1, its end will be 1. Then we'll be entering to this if loop, if condition statement, or else we'll be simply right shifting the num by 1 and incrementing our bit, right? If the rightmost bit is 1, which means that its modulo with 2 will be 1, which means that the current bit has a issue with A or B, which means that we need to increment our count. If hence we need to increment our count anyways if we enter this while loop, if we enter this if statement. And now we'll be checking if the current C bit is 0. Remember, if the current C bit is 1, we will be incrementing either of A or B, and this will be handled by this count statement. But if it is 0, then we have to check if the both of the bits of A and B are 1, then we need to increment our count one extra time, and that logic is handled here. And you can see that our entire logic is built, and now we can dry run an example test case. Let's say, let's consider this example. For first iteration, bit will be 0, num will be greater than 0, and the last bit is different because the OR XOR of the this integer and this integer would be 0 1 1. The last bit would be having a 1 in its bit value. Also, C is 101, so it will be 1. So it won't be entering this if condition. Though our count will be simply incrementing by 1, our number will be right shifted by 1 and bit will be incremented by 1. The next bit is a little interesting. Here we will having 0, so next bit will be entering into this if condition that we skipped previously. And also to note that both of the bits here, both of the bits of A and B are 1. So this condition is also true. Hence we need to increment it extra time, and hence this condition is handled correctly. And we can see that this summation is most optimal summation, and you could build your own logic and little optimize it better. I want to introduce a I want to notice I want to make you notice this thing. Let me go into the description part. This thing I have initialized a bit and b bit only inside the if condition, which means that if the c bit is 0, then only this a and b integer will be initialized and declared. This will save us a little memory, but it won't be affected. You can move this to here and already first, and you could calculate all these bits very first, and then handle and then combine this both as AND condition, logical AND condition, and then increment the count, or you could handle this my way. Anyways, please comment any suggestion. If I know there will be a lot of suggestion in my communication skills, so please suggest them.